these are the major means of attack where users use their funds. So we have reentrancy, we have liquidity pool manipulation, we have high slippage, exploitation, we have dust attack, and address poisoning. So these are the 5 major ways where crypto users are being attacked and how they lose funds on chain. So now we built this system to check for all of this and give user feedbacks before they even send out the transaction. And if a transaction if a transaction will cause loss of fund, that transaction is automatically blocked, and an alert is sent to the user via email so that the user will know what is going on and why the attack was blocked. Yes, so let's do a quick demo of how we can check for reentrancy analysis of any smart contract. So yeah, let's do this. Okay, so I have to remove this. Yeah, so the system can detect any address, be it EVM address, initial address. So now we have, for the demo purpose, we have already set address that you can just use to run this analysis so that you can see how the system works. So we click on here, set the demo address. It's a smart contract that we already deployed on our app chain. So now we click on, I can either click here or here. So if you click on run drill, it's analyzing the smart contract. So now this is the result we found. This is the report by the AI agent. So it says the compiled bytecode reveals withdrawal path that calls the external address before updating internal balances. So the fallback path re-enters recursively. So this is what we call reentrancy hack. So the AI detects this and blocks the transactions from going on. So equally, you can copy, maybe let me get wrapped eating hash address. So this is on Sepolia. You can copy it, then set this to Sepolia, and let's analyze. So click on analyze. It gives you the result. So the result is an EVM address. The contract is upgradable. So the verification state for the contract is unknown, but the fund flow is normal. But on this side, we have that the AI reports that after analyzing the bytecode, we found the following signals. So the contract is not part of allowed wallets in your system, so it's upgradable. But then the most important signals is this. So we found that they have these function signatures: safe destruct, delegate core, and external core. And these are the 3 major attack surfaces that hackers use to drain users' wallets. So this is very useful for keeping crypto users safe on chain. So we also have other checks that we run. This is liquidity pool manipulation. You can equally run an analysis to see. So you can get a liquidity pool address, then paste it and have the system analyze it for you. So you have high slippage exploitation. We also check for this. We also check for dust attack and address poisoning. Also, we also check for stale approvals. So if you have approvals that has been for long, we also check for it, and then we give you a functionality to revoke the approval on the platform. So let's see this. So this is the dashboard. So the address I'm using, I have run some analysis using it for the demo purposes. Yeah, so that's why we get this. Yeah, so these are results that we get from analysis, depending on the security result from the analysis. So you have one stale approval. I mentioned earlier that we also check your approvals from the contract. So the ones that has been